So now we are going to look at scenario 2. I repeat, we are going to look at scenario 2. In scenario 2, we are going to combine VCF files from the same set of samples. This time, we are looking at a situation whereby their variants are in different chromosomes and each chromosome has its own VCF file, such as this example here. We have chromosome 1.VCF, chromosome 2, chromosome 3. All right. You should take note that it should be the same set of samples. So that means that the samples here in this file 1, file 2, file 3, we should have the same number of samples. It's very, very important. So you need to make sure you have that also satisfied. Okay, so let's proceed. Okay, so let's get back to the terminal and then let's proceed. So I'll clear the screen and then I'll proceed. So I'll first do a CD. Then after doing the CD, I am now going to create a directory, a working directory. All right. So which working directory am I creating? I'll say make dir merge chromosomes. Then I will cd into merged chromosomes. Then I am going to download the example data. So let's go to GitHub and let's go to this page again. Okay, so on this page, what we need is this zip file, chromosome VCFs. That's what we need. So again, the link to this page is in the description box. I repeat, the link to this repo is in the description box. So when you are here, click chromosome VCF.zip. You'll be sent to this page. When you are here, I want you to come to raw, this button here, right click and then go to copy link. So this will copy the download link for you. I repeat, right click the raw button, copy link. You can also click this download button to download, but we are going to do it on the terminal. So we'll move straight to the terminal. Perfect. So now on the terminal, I'll say wget and I'm going to paste the link there. I'll use this link. So let's execute the command and then let's get it done. Okay, now it's done. If you do an ls, you should see chromosome VCF.zip. Let's clear the screen. Let's ls. And now let's unzip it. So I'll say unzip chromosome VCF.zip. So I'm going to execute this command. All right, so we have extracted the VCF files. All right, so now if I do an ls, I'm going to find a directory called VCFs. If I ls into it, I'm going to find my files. Okay, so let's proceed. So we can now easily do what we want to do. Okay, now I made mention that to be able to do this, the second approach where we are going to do the concat, we also need to make sure that we have the same number of samples, or we should have the same set of samples in this. Okay, so ideally what you want to do is to try this first. You can just try to see the samples you have in each of these VCF files. All right, so let's even do that first before we proceed. We are doing some form of checks. So I'll just say Bcftools query -l and I'll say VCF/chr1.vcf.gz. So these are the samples that I have. All right. So ideally we should have the same set of samples in chromosome 2. So I'll just record this command and I'll change chromosome 1 to 2. So we should have the same number of samples, the same set of samples. So you can just check from here. All right, I think these are about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, about 12 samples. We should have the same set of samples basically. You can also try with chromosome 3 to see. All right, you can also do this. Let's clear the screen. Just record the command and just say pipe wc-l. So this will give you the number of samples and you can use that to also make some inferences. All right, so basically just make sure that you have the same set of samples in chromosome 1, chromosome 2, and chromosome 3. It's very, very important. Then we can use the Bcftools concat. So now we are ready to do the concatenation. All right, we are ready to use Bcftools command concat. Okay, now let's do this. So that's what we have to do. We need to first index our files. All right, so when I say files, I mean these VCF files. We need to index them, so we'll use Bcftools. So I'll say Bcftools index VCFs. I'll start with chromosome 1. I'll index Bcftools index VCF / chromosome 2. And I'll do for chromosome 3. So Bcftools index VCFs / chromosome 3. I'll index that as well. Take note that with the indexing, if you have several files, maybe hundreds or tens of files, then using this command one by one may not be optimal. There are other ways to deal with multiple sample files. Okay, multiple files. All right, so in those situations, you have to write a script, or you can use SAX to help you do that. But for those who have issues, you can always contact me or book a session and we will look at all these things. All right, so just take note. Some of these things you need to have knowledge in Linux. So I offer courses on Linux for bioinformatics, so those who are interested can also reach out to me. Okay, now let's proceed. So let's do this. We now have our index, so we are ready to roll. Okay, so we will start with the concat. So here too, with the Bcftools concat, there are 3 approaches. I will give one, and all those 3 other approaches, I've covered them in detail in another video, so you can check that video out. The link is in the description box. So let's use one of them. So I'll say Bcftools concat. All right, that's what I'm going to do. And here it's simple. We don't need any other flags. So this is what I'm going to do. So I have Bcftools concat. So I'll specify the VCF file. So I'll say VCFs, because that is where they are. And I'll say star.vcf.jz because I want to merge all these files. And I'll say -o z because I want the compressed VCF. And I'll say -o, that is output file. And I'll say all underscore chromosomes.vcf.jz. So here I say all chromosomes.vcf. So that means that anyone looking at the file will know that yes, these are all the chromosomes. All right. So we have this and we can execute this command. So once you do that, it will do all these checks and then it will give us the final file. So if I do an ls now, I should see this file, all chromosomes.vcf.gc. All right, that's what we have here. Okay, now once we have this, ideally we may want to index this VCF file. All right, so I'll just say Bcftools index and I'll specify the file, the mesh file. So ideally you should index this because some operations, okay, some tasks, some processing will require you to have the index generated for the VCF file. So just to be safe, we will index everything first. Okay, great. Now it's time to validate. It's time to check to make sure that we have the information we need. So again, what we are going to do is to count the number of variants in the individual chromosome files, VCF files, and make sure we have the same number in the merge one. So I'll do for chromosome 1. So I'll just say Bcftools. I'm going to count the variants in chromosome 1 and make sure I have the same number of variants for chromosome 1 in the merge file. All right, so that's what I'm doing now. So I'll just type Bcftools and I'll say view. I'm interested in the true variant, so I'll say -C1. Now this one is just chromosome 1, so I'll just specify it straight away. So I'll say CHR1. No, it's in VCFs, so we have to specify the full part. So that will be VCFs chr1.vcf.gz. Then I'll bring my pipe and I'll say grep-vin-c. I bring my single quotes, caret hash single quotes. So let's count it. Perfect. We now have 208. So the number of true variants in the chromosome 1 file is 208 or 208. All right. Now we need to get the same number in the merged one. So I'll say Bcftools, and I'm going to add the view command. All right. So the view command will be view. And then this time I'll say -c1 again. And here, because we now have several chromosomes in this file, we will need to specify the chromosome of interest. So here it's chromosome 1, which is CHR1. Okay, so I'll just say CHR1, that will come, but I need to add this flag. I'll say -- regions, and I'll say CHR1. All right, and I will specify the VCF from which this information should be extracted. And then I'll bring my pipe grep-vin-c single quote caret hash like this. And I'm going to run this command. So if I do it, I'm going to get 208 as well. That's what you need to take note of. Now, with the chromosome, I said CHR1. All right, this is because in the VCF file, I know that my chromosomes, these are the names. All right, but if you are not sure of the chromosome names, then you can check yourself. Okay, you can just see Bcftools, query-f, bring a single quote, percentage, and say Chrome/n, another single quotes, and specify the VCF file. All right, let's say all chromosomes, or you can use any of the VCF files, any of them, that's fine. And then you can just execute it. So that will let you know the chromosomes you have. Okay, so here I have all these. Now let's clear the screen. I'll modify this command. I'll add sort, and I'll say unique, so that all duplicates are removed. So now we will see that we have this. We have just 3 chromosomes, and these are their respective names. So if you know this, then you can now use whatever you see here in the chromosome label. Okay, it's likely maybe some of your VCF files will have, let's say, 1, or maybe some of you too, if you're dealing with some organisms, you may have, let's say, PF, 3D, 7, etc. So there will be different names. So you need to check using the command I showed, and then you'll be able to put in the appropriate label for your chromosomes. Okay, so that's very, very important. Okay, so that is it for this one. Okay, so you can try and validate for chromosome 2 and 3. Actually, let's do for 2 and 3. All right, so for 2 and 3, I've already done the command. So all I have to do is to just change this to 2 to run it. This is its 2332. So 2332. And I'll do the same for the merged one. So here to chromosome 2. So when I run it, I should get the same number. All right. So now that we've done these two, what I want you to do is to try and do for chromosome 3, and then send me your answers via the chat, via the message section, and then let's discuss it. Okay, that's going to be fun. All right. So that is it for scenario 2, whereby we combine VCFs from the same set of samples, i.e. chromosome 1, chromosome 2, chromosome 3, etc. VCFs. So in other words, we are looking at VCF files with the same set of samples, but then we have them splitted as chromosomes, and we are merging all of them, and that is what we have done here. So let's proceed.